awesome. Thank you. You guys are good. Okay, so on page 49, the sample problem is laid out for you. I don't feel any need to walk through that with you again. But in each of these, we're using this equation. Acceleration average is equal to change in velocity over change in time. This is what we started yesterday. What's another way we can express change in velocity? How do you find your change in velocity? Final velocity minus initial. So v sub f minus v sub I over delta t. That's going to become important. We're going to start deriving some wonderful equations later today. I think I assigned 2, 4, and 5. So let's do number 3 in here. With an average acceleration of negative 0.5 meters per second squared, how long will it take a cyclist to bring a bicycle with an initial speed of 13.5 meters per second to a complete stop? So again, first thing we do when doing any physics problems, what do we do? Actually, I would write down our variables first. Make a list. So the potential variables that we could have average acceleration, we could have delta t. Are we given, well, let's see. We could have a delta v. We could have a delta f, or a v sub f, and a v sub I. All right. Now, let's look at what we're given. We're given average acceleration, correct? What is it? Somebody in blue or green? 1, 2, 3. One of you. What's our average acceleration? Okay, negative, correct? Negative 0.5, is it 0.50? Meters per second squared. Okay, are we given time? Somebody in red. That's 3 of you. What is it? No time. That's what we're being asked for. Okay, are we given a change in velocity? Somebody in orange or yellow. I think that's you.
We're just given initial speed.
Okay, we're given initial speed. Are we given the, what is the initial speed then?
13.5 meters.
Are we given a final speed? Yes, we are. We are. Somebody in black or gray?
0.
0. It asks us how long will it take to come to a stop. When you see the word stop or at rest, that means there's a 0 in there. So our final velocity is 0 meters per second. Okay, so now we know that we're going to use this form. Okay, and we know that we want to solve for delta t. So let's go ahead and rearrange. Multiply both sides by delta t. Divide both sides by average acceleration. And we have an expression solving for delta t. Okay. Now it's a matter of plugging in. Go. Okay, do a quick dimensional analysis on yourself, and I just about screwed it up. I had briefly written the wrong units for velocity. So meters per second divided by meters per second squared will leave you with seconds. That's the unit we want for time. That's the unit we expect. Let's go ahead and we have... Okay, how many seconds are we talking about here? Somebody in white. There are 3 of you that I count. 27 seconds. Delta t is 27 seconds. Is that the correct number of sig figs? Yes. So we're good. We're done. Okay. These are, again, pretty straightforward. These are, for the most part, 4-part algebra. But they're still pretty basic. Questions, comments, concerns? All of 2B is like that. Yes, sir?
So when the velocity is 0, it doesn't get meters per second in the problem?
You know what? Yes, to be technically correct, it should. Yeah, that was a lazy shortcut on my part. So, okay, we good with that? All right, let's turn this off. We'll go back to talking about